All right, so for this problem, we've got the equation of a line and a point in R3, and we want to find an equation of the plane that contains both of these. You can check to see that the point doesn't lie on the line, so the plane that contains both of them is going to be unique. So let's start by remembering how we find the equation of the plane. We need a vector that's normal to the plane and a point on the plane. And then we can just write them in standard form. The coefficients for x, y, and z are the components of the normal vector. And then we subtract off the point component-wise from our three variables. So in this case, we have two different points that we could pick. But we don't have a vector perpendicular to the plane. We do have a vector parallel to the plane for -1, 0. So we need to find a vector normal to the plane, and then we'll be good. So again, we have 2 points on the plane and a vector parallel to the plane. So we need to find a vector that's normal to the plane. But the vector that starts at -2, 0, 3 and goes to 2, 7, 1, or the opposite of it, that vector is going to be parallel to the plane as well. So we can find that vector, the other vector that's parallel to the plane, just by subtracting the 2 points. So 4, 7, -2 is a vector that's parallel to the plane, and 4, -1, 0 is another vector that's parallel to the plane. So both of these are parallel to the plane, and so their cross product is going to be perpendicular to each one of those vectors, and so it's going to be perpendicular to the plane as well. So we're just going to go ahead and cross them, and we're going to find the determinant of this matrix. So 2, 8, 32, that is the vector perpendicular to the plane, or a vector perpendicular to the plane. There's more than one. But now we're essentially done. We've got a vector perpendicular to the plane and a couple of points on the plane. I'm going to pick 2, 7, 1. And so I'm going to write down this equation of the plane. If you had picked a different point or maybe crossed the two vectors in a different order, your equation might look slightly different, but we should be able to get from one to the other, multiplying or dividing. So double check that yours is equivalent to mine, but here is an equation of the plane.